Swap the space. What's it called? Swap the space.
Can you hear me? Yes. Cool. Hi, I'm Angie. I'm from MIT and I'm a PhD student. And this is a joint work with Jared Andrew and Tom Fitterman on integrating Bayesian inference and system dynamics. These are 5 symbols for my presentation that summarizes, and they're going to repeatedly come up during the talk. So since we're in England, we need the Rosetta Stone for how to map the symbols to what I'm trying to say here. And when I use the first symbol, I mean that as a horizontal integration. And when I use the second symbol, I mean that as a vertical integration. And when I use the bridge symbol, that is integrating by bridging organizations. These are the contents of my talk. And I would like to walk you through 2 integrations around dynamics and inference. First by using flu pandemics example, and second by chronic wasting disease policy. And then I want to move on to how the 3 of us, collaborators, have been trying to bridge the 2 communities of Bayesian inference and system dynamics, and what are my hypotheses behind it. Especially, I would like to get your feedback about the last part, how TAN should scale up, and what the role of integration should be in that. Starting with horizontal integration, what I mean by that is modeling tools. So in Bayes, I think for the last 3 days, we have been talking about mostly on that side, how to use HMT algorithm diagnostics in Bayesian modeling tools. But for some problems, we need some dynamic tools as well. And there are softwares like Vensim and communities associated with it. And they are interested in problems like how to represent the modeling decision cases and optimization algorithms appropriate, and how to do the exploration of a model building. So for the first example of a flu pandemics, what it is about is how healthy individuals can become infected through person-to-person transmission, leading to a cycle of infection and recovery or mortality. And this is a doctoral thesis taken from the doctoral thesis of one of the collaborators, Jair, who was doing a postdoc in Cambridge University. And he captured how the multifaceted epidemiology challenges influenced by factors including infection, population density, and public health surveillance efforts. So this is another representation of the formal slide that we have a system of, can everybody see this? Sorry. Can you see the black colors? Oh, cool. So there is a system part and there is observation part, and there is prior distribution. You'll need to look or interpret all these equations. The point is there are key parameters that governs the dynamics of the system, and how Jair put the priors and how the measurement systems are modeled in there. And this is yet another representation that if we set the state variable, I think this was slightly mentioned in yesterday's the panel discussion about SIR model, where the susceptible and infected and recovered people are represented as a square. And different parameters of interest, like beta, rho, are used to represent the dynamics of the system. So in this context, summarizing what I've introduced, I feel a lot of value can be created by integrating the Bayesian tools and dynamic tools, where Bayesian tools offer more accurate and faster inference with and dynamics more exploratory and communicative aspects. And I have prepared 2 integrations throughout this talk. And for the next 30 seconds, please, with the people behind and in front of you, integrate what you think about how this horizontal integration can be helpful to your modeling process.
Can you say what the dynamics do?
What
What
do
do you mean by dynamics here? I still don't.
Oh, dynamics of it within the model throughout the period of time, how certain parameter changes. Like for instance, during COVID, there was a comment that the infection rate somehow changes throughout the period. So that I don't think, as far as I know, is very well represented within STEM, where we have given data and we are supposed to infer the distribution of a static variables. Did I answer your question?
We can maybe take it offline.
Okay.
Like I would think you'd just use a time series there.
Can you model the dynamic changes of the parameters with the time series?
So I think there was a talk about this 2 days ago.
Kind of parameters, right? Time dependent beta parameter.
Oh, great evidence that it's being integrated. So yeah, for this, I wanted to get feedback of like Steve and Elizabeth, because I think they are the members of different value chains of the modeling. So Steve, could you give me a quick comment about how this could help?
I would need some time to think. We can talk after, sure.
Okay. Now, the vertical integration is more about the people. The previous is about the tools, how different tools invented from different communities that has different interests can be used to represent the same problem. And here we have a value chain, modeling value chain members from tool developers to model builders and policy designers and stakeholders. And for this, I prepared chronic wasting disease, which is Tom Federman, CTO of the Vincent software that is kind of a stand in system dynamics community. And he has done a project of modeling the chronic wasting disease, which is about how healthy deer, instead of people, become infected through environment prions and leading to a cycle of infection, mortality, and prion deposition from carcasses. Again, like the flu situation, this is a multifaceted ecological and epidemiological challenge influenced by factors like infection, hunting processes, and population density and environmental contamination. So if I express this in diagrams, you can see the factors that affects this whole dynamics into like 4 things. First, infection, that's starting from the healthy deer to infected deer, which was in previous flu example S and I. And then hunting practices also matters here, which is modeled here. Hunter efforts, it affects the infected deer's infected harvest and carcasses, which affects the environmental price in our environments. So, and also population density matters, their birth rate, and environmental contamination is what I previously introduced. And if I explain this more dynamically, this is a sandbox tool that is embedded in Benzene, and these are the parameters of interest, like how the government should intervene to lower the environmental prions and chronic wastings. So what this tool does is essentially mapping the value of the parameter with the quantities of interest, which is, I think, like Bob said, like time series. And using this tool, Tom has collected the challenges faced by the stakeholders. And these are like low, they have a very low familiarity of modeling, and they care really less about technical details or parameter interest, which I didn't believe at first, but after going to the business school, I realized. And humans' review cycle of the model is much faster than a full model development cycle. So we concluded we need more responsive model. I mean, it should model structured decision-making process and evaluate action proposed by the stakeholders and produce diverse metrics of interest. So long story short, I think diagrams and interactive simulations, like I showed before, is useful for communicating and integrating vertically throughout the stakeholders in a modeling value chain. To summarize, it addresses challenges like stakeholders' familiarity and rapid review cycles and need for responsive and transparent models, which was covered in several of the talks like Anna's multiverse modeling. So I think this integration across the value chain is also needed. I was trying to ask for having a conversation again to exchange how you're modeling in your modeling workflow, how this integration can help. Can we talk with each other, please? Prepare the answer. So how does vertical integration or the horizontal integration change your work, the current model? So like develop an algorithm or library development, how that addresses the flow of Can I get like one answers or like some share of thoughts? Can someone volunteer to share how the integration of different modeling value chain or dynamic thoughts or Bayesian thoughts can help their modeling process?
We basically just talked about you can't just fit a model if you want to use it. Someone has to actually want it. So that's in what you do. That's our basic point. Yeah.
I would say as someone who often builds these interactive visuals on a model, it's extremely custom to the model and the audience. So having a way to do that in a more generic way would be helpful. I don't think this tool, I don't know enough about this tool to say, but it's really nice to have that kind of visual for a stakeholder. But it's a tremendous, like it's very custom to the model, the decision they want to make. And so it's a lot of work to add on. And so I can see the value, but I don't know how easy the integration would actually be in practice.
Thank you.
And just, we were not talking about we were talking about wanting our models. You know, not about that work, that look fine.
Thank you. So that all makes sense because like when I first went into the business school to do PhD, one mistake I made was I thought STEM was the best emperor of the world. I just wanted to sell this to business school professors without really trying to understand their problems. What are their interests? Why they want to model this Bayesian, to model the employee fairness, wages, or climate changes. So I found this interactive tool to be very useful in interactively eliciting their goals of the models. So the last part is about action and hypothesis. And 3 actions that our collaborators are doing is trying to include start from the Benson model, and I developed Stenify that translates the text version of this dynamic model into a STEM and also visualizes in RBase. And similarly in R, this is in Python, and Jer has developed a tool chain supporting translation from another dynamic tools, Stella, which can be integrated with Benson. The both of them are dynamic models into XML format and to R to STEM. So there are existing libraries out there that can be the first step of integrating. So like to summarize this integration across different tools and in horizontally and vertically across different stakeholders and model developers was the key point. And the last 2 slides is just my attempt to apply what I'm learning in strategy to STEM scaling up. This is just a personal opinion. But I try to apply the value creation and value capture of a nailing organization, which is a, like kind of starting like a startup versus scaling situation. So like 5 years ago, STEM maybe specialized HMC algorithm discovering value for existing Bayesian inference users. And their value capture hypothesis was executing on key functional capabilities in probabilistic programming. But as it becomes more popular and different users are trying to use it, I think now it is an integrated Bayesian workflow system that delivers value for new users by providing an end-to-end Bayesian analysis. And the value capture hypothesis is we are controlling some platform that combines model specification, computation, and diagnostics, and post-processing. And one of the lines of works that gives warnings to the scaling organization is some of the, like mostly in this slide. So this is based on my advisor's theory on double helix of integral and modular organization. How in PC industry or auto industry, how different integration has happened. And these factors, 3 factors I just listed in the previous slide, are what enables STEM to scale up. But once you scale up, there are things that you should be aware of that led to the demise of Nokia or General Motors, like tools focusing on specific tasks, expanding capabilities increases complexity, and organization rigidity may lock into its current architecture, making it less reactive to new technical advances and customer needs. So this is the end of my talk, and I hope to have more chat about how STEM could, to what degree STEM is trying to scale up, and how we can avoid these warnings if we scale up. Because I really love this community with you. Thank you.
Time for 1 or 2 quick questions.
Paul?
There's questions there?
So I still struggle a bit because this seems like, also because I'm far away, it seems like a bit abstract to me. So can you give like a concrete example?
So the theory of double helix, you mean?
Like how we would, in which context we would really like want to integrate STEM into this, like with concrete example because like I don't understand a lot of the terms that you're mentioning here organizationally.
Yeah, maybe the last 2 slides were a little stretch, but I tried to explain why I tried to integrate with different tools, because the new users that I wanted to expand to were already had different needs. So like what I felt was, in order to reach to a more diverse users, we need to learn how to make it more integrated resources that people can go to. Did I?
We can discuss it.
So the last, I guess, what I wanted to say was, Bob's comment that's 10 is both the language, algorithm, and community really stuck in me. And I think at first, when we were nailing phase, we were focusing mostly on the performance of 10 HMC faster algorithms. But now I think we need to think more about how it serves as a platform that can satisfy different needs of the modeling as a community.
I'd like to introduce our final keynote speaker, Chris, who's a senior researcher in the Pandemic Sciences Institute at Oxford. He's worked on learning about HIV through genetic sequence data and COVID using contact tracing with mobile phone apps. He's going to be talking to us about the first of these today.
Thank you, Etty. Thank you. Not recording. Thank you, Etty. Thank you to the organisers for the invitation and for organising. I'm Chris Wynant, and so as I was talking about a bit yesterday, I work in infectious disease epidemiology